You know that feeling, right? You've poured weeks, maybe months, into building this slick Delphi app for Android. It looks great, the features are all there, but when you use it, something's just off. A scroll that should be smooth suddenly hitches. An animation stutters for just a split second. It's that little bit of jank that makes a professional app feel cheap. Well, today, we're going on a hunt. We're going to become performance detectives, find the real culprits behind that lag, and learn exactly how to take them down. So let's get started by looking at the fundamental rule that governs everything.
Okay, let's get right down to the nitty-gritty. To make an app feel buttery smooth, you have to understand the frame budget. Think of it like this. Your phone screen is a canvas that gets completely repainted over and over again, really fast. For a standard 60 frames per second display, your app has just 16 milliseconds to do everything it needs to prepare and draw a single frame. That's 16 thousandths of a second. If you're even a microsecond late, that frame gets dropped and the user sees a stutter. It's an incredibly tight deadline. And here's the kicker. On newer phones with those beautiful 120Hz screens, that budget gets slashed in half. You have just 8 milliseconds. That is an insanely small window of time to get all your work done.
So, the mystery is afoot. We've got a crime scene, our laggy app, and a ticking clock. A really, really fast ticking clock. The central question for us as performance detectives is a classic whodunit. If we only have 16, or a terrifying 8 milliseconds to work with, what is stealing all that precious time? What is the thief that's robbing us of our frames and making our app feel sluggish? Well, it's easy to point the finger at the most obvious suspect, but as we're about to see, the real culprit is often hiding in plain sight.
All right, let's dive into who the real performance killers are. When an app feels slow, our first instinct is to blame the graphics. We think, oh, it must be too hard to draw these buttons and lists. We assume the rendering engine is the problem. But most of the time, that's a classic red herring. The visible stutter is just the symptom, not the disease. The real crime is happening way before a single pixel ever gets a chance to be drawn.
Let's just pause on this for a second, because this quote is the key insight to this whole problem. The real bottleneck isn't the drawing, it's main thread saturation. Imagine your app's main UI thread is the director of a play. Its job is to manage the stage, cue the lights, and tell the actors when to move. But what happens if the director is buried in paperwork, trying to calculate ticket sales and manage contracts, all while the play is supposed to be happening? The actors are just left standing on stage, waiting. That's exactly what happens to your app. The main thread gets so busy doing other work that it never even gets around to its most important job, telling the screen what to draw.
So, based on some deep dive analysis, here is the official most wanted list for performance crimes in Delphi Android apps, ranked by how much damage they do. At the very top, public enemy number 1 is visual live bindings, especially when used in lists. Coming in a close second is the abuse of TThread.Synchronize. Then we have our original suspect, the standard FMX rendering engine. It's not innocent, but it's not the ringleader. And finally, we have a situational accomplice called critical section contention. This list is our roadmap. It tells us exactly where to look first to make the biggest difference.
Okay, let's talk about public enemy number 1, visual live bindings. Oh, live bindings. They are the siren song of rad development, aren't they? They seem so magical. You just draw a line from your data to your UI and boom, everything just works. But that magic comes at a truly staggering performance cost. Under the hood, live bindings rely on something called RTTI, or reflection. Instead of fast compiled code, it's like your app has to stop and look up instructions in a manual for every little thing it does. It's constantly looking up property names as text, figuring out expressions on the fly, and managing a whole web of notifications. All of this slow, heavy work happens right on the main UI thread, and it's an absolute catastrophe in lists. When you bind a list, every single item and all of its labels and images can create their own set of bindings. So as you try to scroll, your app is frantically doing thousands of these slow, manual lookups in real time. It completely swamps the main thread, making smooth scrolling an impossible dream.
All right, we've put live bindings in cuffs. Let's move on to our next major suspect, a sneaky one I like to call the synchronization trap. We all know we're supposed to do heavy lifting, like network calls or database queries on background threads, so we don't freeze the UI. That's good. But the trap is sprung when that background thread needs to report back to the UI. How you handle that simple communication can be the difference between a responsive app and a frozen one.
So let's break this down. You've basically got 2 ways for your background worker to talk to the UI boss, TThread.Synchronize and TThread.Queue. Using Synchronize is like your worker stopping everything they're doing, walking over to the boss's office and standing there waiting until the boss is free.
The worker does nothing else until the boss stops their work, handles the request, and says, okay, you can go now. The entire operation grinds to a halt for that one interaction. Now, contrast that with TThread.Q. This is like the worker writing a quick memo and dropping it in the boss's inbox. The worker drops it off and immediately goes back to work. The boss will get to the memo when they have a free moment in between their other tasks. See the difference? Synchronize creates a rigid blocking dependency. Q is a fire-and-forget message that lets everyone keep working independently. It decouples your threads, which is the whole point of using them in the first place.
So, to put it bluntly, TThread.Synchronize is a UI performance assassin. It's a silent killer. You think you're doing the right thing by offloading work, but with every single call to synchronize, you are firing a little poison dart into your main thread. Now, one dart might not do much, but imagine you have a few background threads all downloading things, and they're all calling synchronize over and over to update a progress bar. You're bombarding the main thread with constant interruptions. It spends all its time servicing these little requests instead of doing its primary job, drawing the screen in under 16 milliseconds. That is the source of those rhythmic stutters you see. It completely negates the benefit of multi-threading.
Okay, so we've tackled the two big culprits that clog up your main thread before it even thinks about drawing. Now, let's finally talk about the rendering itself. While it's not usually public enemy number one, the default FireMonkey engine can definitely be an accomplice to bad performance. The good news here is that there's a modern, powerful, and ridiculously simple upgrade just waiting for you to use it.
Let's look at the tale of two engines here. On the left, you've got the classic legacy FMX renderer. It gets the job done, sure, but it's old school. It runs on OpenGL ES, it's pretty heavy on the CPU, and you get those kind of jagged, pixelated edges on things. Its overall negative impact on performance is rated as high. But now, look at the right. This is Skia. We're in the big leagues now. This is the same graphics engine that powers Google Chrome and Android's native UI. It can use modern backends like Vulkan, which are way more efficient and talk to the GPU with much less CPU overhead. The visual quality is just gorgeous, smooth as silk. And because it's so much more efficient, its negative impact is way lower. So you're probably thinking, okay, this Skia thing sounds awesome, but it has to be a huge pain to switch over, right? I'll probably have to rewrite my entire UI layer. Nope, not even close. The beauty of this is that Embarcadero has already done all the heavy lifting for you. Skia is already baked into modern versions of Delphi. It's in there, just waiting. You just have to flip the switch. I am not kidding. This is going to be the easiest, highest impact performance boost you will ever get. Are you ready for this? You open up your main project file, the DPR file. At the top, you add fmx.skia to your uses clause. Then, right before application.initialize, you type this one magical line of code. Global use Skia equals true. That's it. I'm serious, you're done. For that one line, you get a modernized render pipeline, better looking graphics, and more consistent, stable frame times. It is an absolute no-brainer. It's the first thing you should do after watching this. Phew, okay. That was a lot of technical info, I know. So let's boil it all down into a clear, simple plan. What do you need to do right now to fix your app? Here is your 4-step, no-nonsense action plan. Think of this as your prescription for a healthy, jank-free application.
Let's walk through it. Step 1, and this is the big one, declare war on live bindings in your lists. Open your project, find every T-list view, every T-grid that uses them, and perform a live bindingectomy. Rip them out. Replace them with the onUpdateObjects event. Yes, it's a little more manual code, but it's fast code, and that's what matters here. Step 2, become a synchronize detective. Do a global search for TThread.Synchronize. Every single time you find one, challenge it. Ask yourself, does this really need to bring my background worker to a screeching halt? 99% of the time, the answer is no. Swap it for TThread.Q and set your threads free. Step 3, the easy win. Do it right now. Go to your .dpr file, add that one line, global use Skia equals true. Done. Give yourself a high five. And finally, step 4. This is how you go from an amateur to a pro. Stop guessing. Download Android Studio, fire up the profiler, and connect it to your Delphi app running on a device. The profiler does not lie. It will show you, in a beautiful graph, exactly where every single millisecond is going. It's like having performance X-ray vision.
And really, that's what this all comes down to, isn't it? It's about moving away from a world of guesswork and superstition, where we blame random parts of our app, to a world of cold, hard data. Once you fire up that profiler, the game completely changes. You're no longer just guessing, you're diagnosing. You're no longer just a coder, you're a performance engineer. So the real question to leave you with is this: once you've stopped guessing and you run that profiler for the first time, what story is it going to tell you? Because now you know exactly what to look for.